Welcome to Semantic Web Technologies. This is lecture 2. We are talking about semantic web and the basic semantic web architecture. And now we have reached the point that we talk about how to represent simple facts with the help of the resource description framework. In the last lecture, or the last part of the lecture, we have learned what RDF is, and that RDF is simply constituted out of facts, and these facts are built all in the same way, that they start with the subject we are talking about, then there is a property of that subject, and after the property then there's a value of that property. It means we have a subject that is related either to some other resource, to an object, or it is related to some kind of data that is represented as a string or as a literal. Okay, let's look at a simple fact that we have here, given in a graph representation, and then here in the XML representation. Later on, we will also refer to the turtle representation, which will be then, in the end of the course or in the next lessons, the normative or the standard representation. But nevertheless, you should be able also to read the XML serialization of RDF concepts. Therefore, we are doing this now. So what we have here is we have a resource, that's me again, as a URI, and it states that I have a specific telephone number, given as a literal, and on the other hand, I am writing a blog. And here is the URI address of this resource on the web. And first, of course, let's take a look at the simple fact that I have a telephone number. In the XML document that refers to that fact, first, of course, it starts with the XML header, and then you have denoted that this here is an RDF document containing RDF information. Therefore, we need the RDF namespace, and we have, for example, defined a namespace here that we call pers for personal data. Then here, underlined in orange, we have a triple that is stated here as a graph. And here, the triple says that the subject of the triple, it's the RDF description and the RDF about, that is the subject, the RDF about, is here this URI that denotes me. Then, inside that subject, there is the property. And the property here is has phone number. And this stems from our personal example namespace. And then, inside the markup text for that property, there is the literal given simply as a string. So it's pretty simple. This is subject, property, object. If we take a look above to the same or to a similar triple where the object is a known resource, we have the XML serialization below here, again, given with an orange background. So the triple is here again the RDF description. We are talking about me, it's the RDF about, it's the subject. Then again, the same property, the property is here, writes blog in that case, and it's from the same namespace, it's from the personal example namespace. And then, and now this is the difference, when I'm referring to another resource, I put it here inside the angle braces of the property identifier, and there I have another attribute, and the attribute is RDF resource. And the attribute RDF resource has the value of the object we are talking about, so of the block, or the URI of the block. And that's simply a triple that is referring to a resource as an object in the XML serialization. Now this is pretty much to write, and you can, of course, according to the rules of RDF and XML, make some shortcuts in there. So for example, a shortcut might be that you can state these two facts, of course, in one RDF description. Then you have here the subject above, again me. Then you can, for example, the phone number also encode as an attribute of the RDF description markup tag. You remember previously we had an own markup tag, But what you can do here with so-called data type properties, which have literals, you can encode it also within the subject with the help of a special attribute that comes from the namespace that you have defined above here. And then you can say has phone number, and then you have the attribute value within quotation marks. And then, for example, I can switch to the second property rights block, and here I have again defined an own markup tag with an attribute of the resource I'm talking about here, about RDF resource, and here the URI of the resource. So this is simply a shortcut in writing. Okay, let's take another look, for example, what we have learned some lectures before and some parts before in that lecture, that if I'm talking about a specific person, the person, of course, itself is not transferred via the HTTP protocol, but only information about that person. But if I want to talk about the person, I have here, for example, a file where information of the person is provided, and inside that file I have also an identifier created that marks up me, myself, as a person. So it's here denoted as, here you have the file name, then you have the fragment identifier, this hash, and then you have my name as a fragment identifier within that file, and we are talking about me as a person. And there again, I have a telephone number, and of course I am writing a block. And if you want to refer to this fragment identifier, then the language or the XML serialization changes a little bit. So for example, in the end, of course, I would have to use this entire URI to talk about myself. But as a shortcut, I can define a so-called base URL. I can define a base prefix that will always be used for all things and for all fragment URIs I am using inside this XML file. So with XML base, I define here the URI hpi-web.de lecturer as the prefix that will be put in front or extends the fragment identifier you see here, and that is denoted as hash Harald Sack. So here again, I have represented these two triples as before, only I'm talking about now in the about identifier, not with the whole URL, but I'm using here the prefix base identifier, and this is a shortcut, and then of course I have to write less. Let's take a look at the next slide. Here I have a shortcut, and we can again first look at the shortcut, which you can see here. I define two prefixes in turtle. The blue ones are always turtle. And we define here a prefix for RDF and for the personal namespace I have here, and I can define a base prefix, the same as you have seen in the XML serialization. Only in Turtle, it's much shorter. You simply state here prefix, and then you define, here's the prefix given, that's the prefix string, and this is the prefix the string here stands for. This is pretty short. You have only 3 single RDF statements that already define all your prefixes you note. And later on then, these two triples can be represented in the following way. I'm talking about me, Harald Sack. And here you see that here, this is also only a fragment URI that will be extended here with a base identifier. This here is the URI from the personal namespace, and this will be extended with this URI. So you can here simply write that I have the telephone number you see here in quotation marks as a string. And then this triple ends not with a period, but with a semicolon. And this stands for the fact that this subject is not closed by the period, but it will continue, and I will continue talking about that subject. It means I can add another property, writes block, and here comes the URI of the object of the block I am talking about. So you see in Turtle, this is pretty short, so it's much more convenient to encode these things in Turtle than in XML, especially if it comes to more complex facts. I give you another example or an extended example, again now in XML serialization. So for example, if you look here, if I want to talk about, let's say, again, this fact that we have seen here, I can talk about me, myself, also without referring to that hash or to that fragment identifier. I do not have to use it. If instead of RDF about, I'm using here the term RDF ID, because RDF ID always is extended or complemented with this hash, and you don't have to write it. So simply to keep that in mind. So you see this here refers to the entire URL, and of course, it always relates to the base URI you see here. In Turtle, this is pretty much shorter. You see here, I do not have the idea. Here, I always do not need the hash sign in front here of the fragment identifier. This is automatically here endorsed. Especially, I also don't need the base identifier if the base identifier refers to the name of the file we are talking about. So for example, this RDF information, this Turtle information is encoded within this file that has this file name, so this would be the base identifier. And if I do not denote the base identifier explicitly, always the file name will be kept for the URI of the entire subject or property or object we are talking about. So you see, in Turtle, sorry, in Turtle, this is pretty convenient and pretty short. Okay, let's take another example. Here, for example, I want to make the statement that this here is a lecture, and this lecture has a name. The name is Semantic Web Technologies, and the property here is the lecture name. And the lecture name contains a certain amount of time. It comprises 4 hours a week, for example. So this is the property for the duration. I can encode that again in the RDF XML serialization, and you see here I have an RDF description for all the triples I want to denote. I am talking about this lecture. I denote this with RDF about, and what is here new is I now introduce data types simply to show you that, for example, this here is a string and this here is an integer. And this, of course, I have to do with the help of XML schema data type definitions. And here, for example, I'm using the name of the lecture I have here, the lecture name. Please remark here that I have a prefix defined here for the lecture URI. So therefore, I only need the prefix and then the name. And then I state that here, this data type property, this literal I'm referring to, has a specific data type, and here it's the data type, RDF data type, it's the code word, the attribute for that. It's an XML schema defined string, and the string is Semantic Web Technologies. And the other one here, it's the duration. This is defined as 4 hours, or 4 simply as an integer number, and therefore I take the RDF data type XML schema integer. So pretty convenient. I can state the data type here as an attribute within the name of, or the definition, the markup definition of the property. So these were some simple examples how to encode knowledge, how to encode simple facts. The next thing that we want to do is, first, we also want to talk about objects and about resources that do not have to have a name. So we want to make existential assertions, for example, without denoting specific individuals. We do this with blank notes. And of course, sometimes we want to talk not about single individuals, but we want to aggregate individuals into sets, and therefore we need something like lists. And this will be subject of the next part of the lecture.